Okay, today I'm going to do question 11. Okay, before I even start question 11, I'm just going to use Graphmatica to show you what the solutions actually are. Then later on, I'll actually do the actual calculations to find the solution to the question. So basically, the question tells us there's a line 4y minus 3x equals to 7. So on Graphmatica, I'll draw that. This is 4y minus 3x equals to 7. Then it meets a curve 3x squared minus 8y equals negative 5 at P and Q. So let me draw that graph also. Okay, notice that the line will meet the graph at 2 points. One of them is P, one of them is Q. Maybe we call this guy P and call this guy Q. Okay, so it meets them there. Now the question asks, okay, what is the gradient of the curve at P and at Q? Okay, now again we use our friendly friend again, the calculus tool. Then I draw tangent, okay, at this point at P. Okay, notice right that the answer here, okay, when I've drawn the tangent to the graph at P, the answer, the slope is, or the gradient is, negative 0.75. Similarly, okay, if I were to draw my tangent, okay, at Q, okay, they draw the tangent for us there, the calculated slope is 2.25. Alright, now I'll switch back to the paper and to do the pen and paper calculations. Right, and here we have it. Okay, first right, we have the line and the curve down here. First thing that happens is that we will start to solve the two of them simultaneously. Why I do that is because I actually want to get the value of P and of Q. So all this working here is the very earlier part of A maths, right, where you solve, okay, to find the intersection points P and Q. So okay, maybe I'll name this guy P, okay, so it make more sense for you, and name this guy Q, okay, 3 and negative 1. As we have learned in question 8c, the first derivative will give me the what I call gradient of the graph. So now, how do I manipulate now? I need to be able to differentiate my curve. Okay, so what I get is I start with 3x squared minus 8y equals to negative 5. So I will start to manipulate my equation. So what I get is 8y, okay, is equals to 3x squared plus 5. Then if I simplify, y equals to 3 over 8 x squared plus 5 over 8. Here is where we call upon our good friend the first derivative. Okay, so our first derivative will be, I will differentiate with respect to x the function y. So I'm differentiating y with respect to x. Okay, first one I'll get 2 times 3 over 8 is 6 over 8. Okay, so I write down 2 times 3 over 8 x squared, the square minus 1 is x to the power of 1. Here, number when you differentiate, it becomes nothing, it becomes 0. So my gradient function, okay, is equals to 1 for 3/4 x. Then now I will say that for at P, okay, my x value was equals to negative 1. So I will get my value of 3/4 times negative 1. The gradient is negative 3/4, just like what we saw in the Graphmatica just now. Similarly at Q, okay, my dy dx, where x is equals to 3, I take 3/4 and substitute in the value of x is equals to 3. I will get 9 over 4, which is equals to 2 and 1/4. So the gradient at P is negative 3/4 and the gradient at Q is 2 and 1/4, as we have seen earlier in the Graphmatica video I shown earlier. And that's the calculations and the concepts needed, right, from the first derivative. Thank you for watching.